So we start off with the series this time around, and in series we have arithmetic series as well as geometric series. uh, to begin with. Okay, so so the general notation is A1, A2, A3 up to AN, and the summation is A1 plus A2 plus A3 plus up to AN. Okay, for the arithmetic series, uh, we start off with the general forms. So we have this series which says the nth term is equal to a1 plus n minus 1 into d, where an is the nth term, a1 is the first term, and d is the increment, n minus 1 is basically the multiple of t, which is the increment, and n minus 1 is actually the number of terms minus 1. Okay, so d here is a2 minus a1 is equal to a3 minus a2, if you know what I mean, and so on. A4 minus a3, that makes it a series, and the summation is up to n terms. Summation k is equal to 1 up to n, and a1 plus k minus 1 into d. This is the general form for summation. So for example, we have a series 1, 2, 3, 4, and so on. So 1 plus 2 plus 3 plus 4 and so on would be the summation. So a1 is 1, a2 is 2, d is a2 minus a1, which is 2 minus 1, which is 1. And then the nth term, for example, if we are to find the fifth term, then it would become a1 plus 5 minus 1 into 1. Yes, so the fifth term would be, in this case, 1 plus 4 dot 1 is equal to 1 plus 4 is equal to 5. Yes, so this is example with numerical values, and if you are to find sum up to 5 terms, the summation will say k is equal to 1 up to 5 a1, or 1 plus k minus 1 into d, which is 5 minus 1 into 1. In this case, it says so this will open up k times this thing, and it will give us each time it will give us different results. So 1 plus 2, first term, second term, third term, fourth term, and fifth term. So this gives us 15. Yes, Okay, for example, sum up to n terms is uh, 1 plus 1 minus 1 into 1 plus 1 plus 2 minus 1 into 1. Yes, uh, this we're just checking the form for the summation. So this becomes 1 and this becomes 2. 1 plus 2 is equal to 3. So this is sum up to 2 terms. So this is how we use this form for analysis. One more thing that needs to be pointed out is the harmonic sequence. Okay, so this is the reciprocal of the arithmetic sequence. Harmonic sequence is, let's say we have a sequence which is arithmetic a1 plus a2 plus up to an. The harmonic sequence is 1 by a1 plus 1 by a2 plus up to 1 by an. So what we do for the solutions is we rather convert it back to the arithmetic sequence and solve. For example, first for the nth term we have the formula which says a1 plus n minus 1 into t, and for sum up to n terms it says once we have this nth term, then we can do 1 by an for every term. For each term we can we can inverse the arithmetic sequence into harmonic, or once again invert it back to arithmetic and solve, and then we can go further with finding the terms. And when it comes to geometric sequence, which is important, the nth term is a1 or n minus 1. First term, the ratio r and to the power n minus 1, where r is a n by a n minus 1, the or simply a n plus 1 by a n. The next term divided by the previous term gives us the ratio. So in such a case, when we have a sequence which says a1 plus a2 plus up to an, so r would be a2 by a1. Okay, so this would be r, and for example we have a sequence which says 1 plus 2 plus 4 plus 8 plus up to whatever limit we put. Okay, so a1 is 1, a2 is 2, r is a2 by a1, which is 2 by 1, and which gives us basically 1. Yes, yes, you see. So here we have 2 by 1 is equal to 2. So the ratio is here, and the nth term, for example a5, the fifth term would be 1 multiplied by ratio to the power 5 minus 1. Yes, so that would be 1 dot 2 to the power 4, which would be 2 to the power 4 is 2 dot 2 dot 2 dot 2. This would be 16. Yes, and if we are to find the sum, so that we have this form, Sn is equal to the first term 1 minus the ratio to the power n by 1 minus r, and 1 minus r should be non-zero to have a realistic solution, real and not complex. And the example we have is, as we mentioned, 1 plus 2 plus 4 plus 8 plus up to whatever. So an is a1 rn minus 1, so a5 we spotted to be 1 dot 2 to the power 5 minus 1, which is 16, and sum to the power 5 is 1 minus r, which is 2 to the power n minus 1, n, sorry, 1 minus r to the power n, which is 5 in this case, and now divided by 1 minus r. Okay, so this gives 1 minus 32 by minus 1. This is minus 31 by minus 1, or 31. The sum up to 5 terms is 31. Okay, just to check the general form once again, to remove any remnant of the doubts, if we have to find a3 with this form, the third term, that says, excuse me, removing the debris, a3 is in general form a1 r 3 minus 1. Yes, so this is 1 dot 2 dot 2 to the power 2. So this is 4, and we can spot first, second, and then the third term, which is 4 here, and sum up to 3 terms would be, in this case, 1 minus 2 to the power 3 by 1 minus 2. Yes, so 1 minus 8 by minus 1 is equal to minus 7 by minus 1, which is 7. So this is doable. 1 plus 2 3, and 3 plus 4 7. Yes, this is thing. So this is how we can estimate the basic parameters of a geometric series. So binomial theorem, and series theorem and series. Okay, for theorem, excuse me, I'm reverting the sequence. For series, we have this form 1 plus x to the power n, and it opens up